All right, so I'm going to work a few examples here. These are found on page 307 in the text, page 307. And the ones you should be able to work for, well, I guess it has to be homework. The ones you should be able to work for examples for practice are on page 307, numbers 23 through 28. And I'm going to work number 24, a few of these, just to sort of give you a feel and to work some examples out here. So, number 24 says, find the area under the standard normal curve to the left of the given z-score. We're asked to find the area to the left. All right? So, we're given the z-score. Z is equal to 2.56. So z is equal to 2.56. Now previously we've discussed how to take the 2.56 on the margins of the table. Remember, this was our standard table. We looked up 2.5 and 6 on the margins of the table, and then we looked in to find the table value it came from. So if we know how to find that table value, now we're going to put some legs to that and see what that represents. So, area under the normal curve. Area under the normal curve, every time you're going to draw this picture. One picture per problem. Never try to work more than one problem on a picture. One picture per problem every time. Draw the normal curve. Now, of course, I cannot expect your normal curve to be the high professional quality you see in front of you here. If yours is a little bit less perfectly drawn than this, that will be fine for your purposes. Remember that the bottom scale is the data scale. Now, this particular problem has nothing to do with what's on the X scale. So, again, this is rather like we joined this problem already in progress. We imagine that we've already taken a number from the data scale and translated it up to the standard or the Z scale. Now, what do we know about the Z scale? We know it is centered at 0. And our value in our z-score is 2.56, which is positive. So all we need to do is place it over here to the right. Again, don't worry about the distancing, just make it look easy to work with. And this is the 2.56. Always draw a line immediately above it, so these are aligned. And the arrow we draw always goes to the left. This is a left-handed table that we're using. Different textbooks do different things, but our text uses, and this is probably the most standard, which is a left-handed table. This is the area to the left of the value in question. So, if we look up 2.56 in the table, 2.5 around the edges, 2.5 in the Z column, and in the Z column on the leftmost or rightmost, whichever is easier. And we're in the 0,6 column, and wherever that row and that column intersect, 2.56, that corresponds to the value. See if you can find it. It would correspond to the value 0.9948. So the table value is 0.9948. Conceptually, it would be something like this. You would look up 2.5 and 6 in the column, and wherever they meet, this is the 2.5 row, the 0.6 column, wherever they meet, that's the 9948. So conceptually, that's what's happening. That's not the detail work. So that's the table value, and remember that the table value always goes on the arrow. So we have 0.9948, the interpretation of which is 0.9948 gives the value to the left. This table is a left-handed table. So what we have found is the area under the curve that lies to the left of 2.56. Remember, the total area under the curve is 1. This is 0.9948, so this is most of the area of the curve. This table always gives the value to the left. If that's what you're asked to find, then you're finished. Well, in this case, that is what we're asked to find. We are asked to find the area to the left. This gives us the area to the left. And so find the area under the standard normal curve to the left of the given value. Our answer is 0.9948. Let's see if we can work number 24. Let's work. Let's say part C, as in cat. So part C says the given z value is negative 0.94. Z is negative 0.94. Every picture gets its own normal curve every time. That's the data value scale. That's the standard scale. We know this is centered at 0. We joined this problem already in progress, so we assume we've done everything with the data scale. This is 0. This z-score is negative, so we know we are to the left of 0. Any z-score that's negative must be to the left of 0. Any z-score that's positive must be to the right of 0. Extend this line upward and draw the arrow to the left. Our table always finds values to the left. And so, go to the standard normal table, look up negative, make sure it's negative, not positive, negative 0.9 in the leftmost column. Look over until you in the 0.4 column. I have 0.1736. Negative 0.9 gives us the row. The 0.4 gives us the column. The value we're looking for is 0.1736. So the table value is 0.1736. That goes on the arrow, 1736. 1736 always goes on the arrow. That is always this region, which I'm labeling here in green. So 0.1736 is that value. If that's what you're being asked to find, then you're finished. That is what we are being asked to find. That's the value to the left, and so we are finished. So the area under the normal curve to the left of 0.94 is 0.1736, and we are finished.